fraction to percent. The word percent comes from the Latin word centum, which means 100. So does the word cent. A cent is 1/100th of a dollar. Percent means per hundred or out of 100. So you can express this as a few different ways. You could express this as 100 over 100. You could express it out of 100 out of 100. You could even express this as 100 hundredths. And if you wanted to express this as a decimal number, when we divide 100 by 100, we get 1. So how do we express percents as words, fractions, and decimals? Well, 25% is 25 out of every 100. As a fraction, we would write it as 25 over 100. And for now, we're not going to worry about putting fractions into lowest terms. We're just going to write a fraction over 100. And as a decimal number, 25 hundredths looks like this, where our 5 is in that hundredths position. So what if we're not giving a percentage, but we're given a statement in words? How do we express that as a percent? Well, 18 out of every 100 is 18%. As a fraction, that looks like this, 18 out of 100. And 18 hundredths look like 0.18. Always make sure you're putting the 0 in front of your decimal place. That is good, proper mathematical format. And you want to include your 0 in front of your decimal place to earn full marks on any quizzes, assignments, or test. What happens if you are given a fraction? So 72 out of 100, that would be what this means in words. 72 out of every 100, which is the same as 72%. Which is also the same as 0.72. Make sure that your last digit in your number is in the same place value as your denominator. So make sure that your 2 in this case is in the hundredths position. And lastly, what if you're given a decimal number? Well, this means 87 hundredths. So I write that over 100. That's the same as 87 out of every 100, which is also the same as 87%. So now that we know how to quickly convert between a percent, a fraction, and a decimal, knowing that we are not going to worry about putting our fractions into lowest terms, now let's take a look at what does it even mean? So what does this look like visually? Well, here I have a large square that is split up into 100 pieces. So if I wanted to take a look at this visual representation, I would count how many squares I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 squares out of 100 are shaded in. What does this look like as a percentage? This is the same as our numerator, so 10%. And what does this look like as a decimal? It looks like 0.10 or 10 hundredths. I include my 0 here because it's in the hundredths position, but also know that this can be expressed as 0.1, which also means the same thing. So we don't have to include our trailing zeros after our decimal place when they are in the place values that occur in our decimal places, so tenths, hundreds, thousands, so on. Now let's take a look at this next example. Again, I want to figure out how much of this shape is shaded in. So I start by counting my squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and 36. So 36 out of 100 squares are shaded. Our percentage is just the numerator, so it's 36%. And as a decimal, it's 36 hundredths. So I have to make sure that my last digit is in the hundredths place value. Now let's look through some more examples. So what happens now if I have to shade in my own squares? Well, I know that I have to, as a fraction, 27 of these squares need to be shaded in. Each row and column are 10, so I'm going to shade in the first column, so that's 10. It doesn't have to be pretty, but they do need to be shaded in. I'm going to also shade in my second column, the entire thing, so now I'm up to 20, and then I shade in 7 of my other squares. So 1, 2, 3, 4, 5, 6, 7. So this is what it looks like visually. So now I can write this as a percentage, so 27%. So it's always the same as your numerator in the fraction. And as a decimal is 0.27 or 27 hundredths. So the 7 is in the hundredths place value. What about the next one? 72%. What does that look like? Well, that is 72 out of 100. So I know I have to shade in 72 squares. It can be any 72 squares. I don't have to shade in an entire row. I could do completely random, but I'm going to go ahead and do that. So this time I'm going to do rows instead of columns. So I'm going to shade in 10, 20, 30, 40, 50, 60, 70, and 2. So again, it doesn't have to be pretty, but they do need to be shaded in. And how do I express this as a decimal? This looks like 72 hundredths. My 2 is in that hundredths place value. Another way to think about converting between a fraction and a decimal is to take the numerator and divide by the denominator. So 72 divided by 100 will also give you that decimal place. Also, so I could go 72 divided by 100. And to get from a fraction to a decimal, or sorry, a fraction to a percentage, you would take just the numerator. So that's our trick there. To go from a decimal to a percent, you might remember that we should be multiplying by 100. And obviously we know from our previous lessons that to convert a decimal to a fraction, we look at our last digit. This is in the hundredths position. So I place that over 100. So that's to get to that back to that fraction. So those are just some tricks on how to convert from one to the other. There are multiple ways to get to these answers. You may know a different method. As long as your method works consistently every single time, then that is perfect. If you have any questions about this or any of the other things that we are working on in this course, please send me email or sign up for a virtual help session, okay? All right, let's keep going. So let's figure out what we're going to fill in. I know this is formatted a little strange, but we're going to fill in the missing percent in each of the pie charts below. So I know that a whole circle is 100%. I know that this section of my pie is 46%, so I'm going to subtract those. So you may know subtraction methods in a few different ways. You might think about borrowing. You might think about some estimation strategies that help you out with this. Lots of different methods. You could use counters. You could use a calculator. Try to do this mentally if you can. Okay, so I'm going to, instead of making this 0, I need to make this a whole number, so a number that's larger than 0. So I need to go and make this 10 and 9, and this becomes a 10. So 10 take away 4, or 6, sorry, is 4, and 9 take away 4 is 5. So the missing portion is 54%. I have to include that percent sign because that's the unit that I'm dealing with when I look at pie charts. For the next one, I may want to add up the percentages that I know first of all. So I'm going to take my 31 and I'm going to add it to my 27 to get this total portion that is in there. So 1 plus 7 is 8 and 3 plus 2 is 5. Now I'm going to take my whole, which is 100. So a circle is 100%, and I'm going to take away this entire section, which is 58%. So again, I'm going to use my strategies of subtraction. So I'm going to turn this 10 into a 9 and add a little 1 there to make this 10. So 10 take away 8 is 2, and 9 take away 5 is 4. So this section right here is 42%. So I have to include my percent sign because that's the unit that I'm dealing with when I'm looking at pie charts. A few more sort of word problems. Using the sale poster on the right, determine the percent of the regular price that you would pay. Well, normally an item that is not on sale you would pay full price for. So a regular price object, which is full price, is 100%. If I'm taking 30% off, so my sale or my discount is 30%, in order to find out, I'm actually going to take the word discount off of this, sale, sorry, and just keep discount. So the discount I'm taking is 30%. So what is my sale price? So in order to calculate that, I need to subtract the discount that I am taking from my full price. So that becomes 70%. So I'm going to pay 70% of the regular price for whatever the item happens to be. So therefore, I'm going to write my concluding statement. Therefore, you would pay 70% of the regular price. And the last question, on a test you received a mark of 74%. Tests are out of 100%, okay? Sometimes they're worth out of something different, but when we're thinking of percent, a perfect test is 100%. If you received a mark, so your mark was 74%, So these are all the answers that you got correct. What percentage did you get wrong? So I'm going to go ahead and subtract these again. So I'm using my rules of borrowing to help me subtract this. 10 take away 4 is 6, and 9 take away 7 is 2. This is a percentage, so 26%. So 26% of the questions I got wrong, and that would be my concluding statement. So therefore, 26% of the questions were wrong. If you haven't seen this symbol before, so this is the triangle that I've created using 3 dots. This is a symbol that we use to represent the word therefore. So mathematicians are lazy. We don't like to write out the entire word most of the time. And that's why we use symbols and numbers and equations. So it's important for us to realize that sometimes those symbols that we use can be representative of actual words. So this is just a symbol that we use to start a concluding statement which represents therefore. So therefore, 26% of the questions were wrong. If you have any questions at all about any of the topics in this lesson, please reach out to me, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.